So in this part we are going to learn about the we are going to solve the numericals which are based on the chemical kinetics. So let's see first which type of numericals are asked and on which topic. So the numericals on chemical kinetics. The numericals are asked on the rate of reaction. After that, it is asked on the rate law and order of reaction. It is also asked on the first order and zero order reaction. Generally, the question is asked on the same, that is the first order and zero order. In this case, either they ask the question on the rate constant or on the half-life period, that is T half. Generally, it is from the first orders. From zero order, very rarely they ask the questions. Then next, the questions are asked from the mechanism of the reaction, that is a complex reaction. Like in this case, they give a complex reaction, their steps and all, and then you have to determine the rate law for a given reaction, which depends on the rate of the slowest step. Then finally they ask the questions. The questions are also asked on the Arrhenius equation. Arrhenius equation, which gives the relationship between the rate constant and the temperature. They are directly proportional to each other, so question related both of them. So these are the different part of the chapter on which the numericals are asked. That is rate of reaction, rate law and order of reaction. Generally the question based on this, it is the combined questions only. Then first order and the zero order reaction question is based on the rate constant and the half-life period. Then about on the complex reaction, and then finally Arrhenius equation. Okay, so the numerical based on the rate of the reaction. The first numerical, the question is, in the reaction A plus 2B gives C plus 2D. The rate of change of concentration of A is 2.8 into 10 raised to minus 2 molar per second. Calculate. Number 1, we have to calculate the rate of reaction. Number 2, we have to calculate the rate of consumption of B. And then third, we have to calculate the rate of formation of D. So here it is given part is the rate of change of concentration of A. Now in the reaction I can say that A is a reactant, and being a reactant, that change is going to be the disappearance, or I can say the consumption. During the reaction it is going to be consumed. So first we have to calculate the rate of reaction. The rate of reaction is always equal to the rate of consumption or the formation of that component whose concentration is, which is 1 mole or whose coefficient is 1. So here I can say the coefficient of A is 1. So the rate of reaction and the rate of consumption of A is going to be same. If I'm talking about the consumption of B, then rate of consumption of B, how many moles of B is consumed here? I can say 2 moles. So, and how many moles of A is consumed? 1 mole. So I can say that the consumption of B is going to be exactly double of the rate of consumption of A, or I can say it is going to be the double of the rate of reaction. Then rate of formation of D. During a reaction, how many moles of D is forming? Then I will say 2D. So 2D, that is double of A. So again I can say the rate of reaction is going to be, so rate of formation of D is going to be the double of the rate of consumption of A, or I can say it is going to be a double of the rate of reaction, because the rate of reaction is always written for the 1 mole of reactant. So if it is 1 mole of a substance, and if it is 2 mole, so double of rate of reaction. So directly we can write the answer without solving anything. Now suppose if I wanted to solve, then how it is solved. So solution part. First we have to write the rate of reaction, but before that it's a rate of change of A, but as I said it's a consumption. So the consumption of A is written as minus dA by dt. Minus stand for that consumption or disappearance. It is equal to 2.8 into 10 raised to minus 2. The unit is molar per second. We have to write the rate of reaction. So first, rate of reaction, that is rate is equal to, as I said, rate is always the rate of reaction is always equal to the rate of consumption or formation of the component, which is of 1 mole. So here the rate of reaction is equal to the rate of consumption of A, or it is going to be formation of C, or it is going to be the half of the consumption of B, or it's going to be the half of formation of D, because they are 2 moles. So finally we have the value of A. So rate is equal to minus dA by dt, which is equal to, I can say, minus dA by dt is 2.8 into 10 raised to minus 2 molar per second. Then B, we have to calculate the rate of consumption of B. So rate of consumption of B, as I said, B how many mole? 2 mole. So consumption, so it's a minus dB by dt. It is going to be the twice of rate of reaction. So rate of reaction is this. So it is going to be 2 into 2.8 into 10 raised to minus 2. That is equal to 5.6 into 10 raised to minus 2 molar per second. C, the rate of formation of D, the formation, so no minus sign, so only d by dt, it is equal to, how many moles of D is forming? Simply I will say 2 moles, so it is going to be twice of rate of reaction. So it is going to be 2 into rate of reaction is 2.8 again. That is, the answer is same, 5.6 into 10 raised to minus 2 molar per second. Now in this case I can say that B and D, the coefficients are same, means they are in the same ratio, and if they are in same ratio, so their consumption or the formation value is going to be same. Similarly A and C, they are again present in the same ratio, so the consumption of A and the formation of C value is also again going to be same. Now the second numerical based on the rate of reaction. The reaction is, there is a reaction 2P gives 4Q plus R. The question, it is given that concentration of Q is found to be increased by 2 into 10 raised to minus 2 mole per liter in 5 seconds. Calculate the number 1, the rate of appearance of Q, number 2, rate of reaction, and the number 3, we have to calculate the rate of consumption of P. So there are 3 questions. The first given is, the concentration of Q is found to be increased by, means this is the change in concentration of Q. In how much time? 5 seconds. So we are having 2 data, that is a time interval and the change in concentration of Q. So from that we will get the rate of change of Q, and that change is going to be a appearance, or I can say formation, because it is a product. Then we have to calculate the rate of reaction. Once I got the change, the rate of formation of Q or appearance of Q, then I can say the rate of reaction also. That is going to be 1/4 of this. And then rate of consumption of P. So solution now. The given part is the change in concentration of Q. We have to calculate the rate of appearance of Q. So rate of appearance of Q, that is dQ by dt, I can say. dQ by dt, change in concentration of Q, which is given as 2 into 10 raised to minus 2 upon time interval is given as 5. 5 4s are 20, that is going to be 0.4 into 10 raised to minus 2. Unit is going to be mole per liter per second. Or it can also be written as 4 into 10 raised to minus 3 mole per liter per second. Okay, this is the answer for the first one. Second, we have to calculate the rate of reaction. The rate of reaction is always written for the 1 mole. And how many moles of Q we are having? 4. So this is the value for the 4 mole. So for 1 mole, it is going to be 1 upon 4 times of the dQ by dt, that is consumption of formation of Q. So it is going to be 1 upon 4 into 10 raised to minus 3. That is equal to 1 into 10 raised to minus 3 mole per liter per second. Third one, we have to calculate the rate of consumption of P. So rate of consumption of P is equal to, rate of consumption of P means we have to calculate minus dP by dt, which is equal to, Now the rate of consumption of P is 2 moles. In the reaction it is given 2 moles. 2 moles, so it is going to be twice of the rate of reaction, that is 2 into rate. And the rate is 1 into 10 raised to minus 3. So answer is going to be 2 into 10 raised to minus 3 moles per liter per second. So these are the answers for these 3 questions. Now the next we are having a numerical based on the rate law and the order of the reaction. So here we have the first question. For the reaction 2 moles of NO plus Cl2 gives 2 moles of NOCl. When the concentration of both the reactant is double, the rate is increases by a factor of 8. But when only concentration of chlorine is double, the rate double. What is the order of reaction? So finally here we have to calculate the order of reaction. But to get the order of, what is order of reaction? It's nothing but the sum of the powers of the concentration term in the rate law. Means if I wanted to the order of reaction, then first for that we have to find out the rate law of the reaction. So first we have to rate law, that it means ultimately the full game is of the values of x and y. Some data is given and from which we have to deduce the values of x and y. Now how to solve? While doing the theory part, we had considered the one example, that is the example was 2 moles of NO plus O2. This is only for the reference, not related to this one. So 2 moles of NO plus O2 gives 2 moles of NO2. The rate law was rate is equal to K into molar concentration of NO raised to 2 and O2. This was the rate law. The values of x and y is 2 and 1. It is experimental value, means I can say the reaction is elementary reaction in short. Okay, that time I said that if I'm increasing the concentration of NO, if I'm doubling the concentration of NO, then how it affects the rate of reaction. So if I'm doubling the concentration of NO, rate dash will be equal to K into double of NO. Just NO is double. So what number is coming outside? 4. That is 4 into K into NO whole square and into. Since 4 comes outside, so I can say that it is going to be the 4 times of the rate of reaction, because this is nothing but the original rate. If I'm doubling the concentration of O2, then what happens? So rate is equal to, rate double dash will be equal to K into, now we are doubling the concentration of O2, NO whole square into concentration of O2, twice of O2 because we double. Now how much it will affect the rate of reaction, that doubling of oxygen, how much it will affect the rate of reaction, it totally depends upon that which number is coming outside. So since the power is 1, so only 2 will come outside, and then left quantities are the K into NO whole square into O2. And this left quantity is nothing but the original rate, that is the rate of reaction changes by this. So rate of, on changing the concentration of any reactant, how much the rate of reaction change, it totally depends upon that which number is coming outside from the bracket, and it depends upon the power, which we have to calculate in this case. Now from this numerical, now how to solve the same question within a very short time period. Okay, the solving method is a different, but how to solve it in a very short time. Now we have 2 conditions. First, at least we come to know that the reactants are NO and Cl2. So I will just consider rate is equal to K into molar concentration of NO and molar concentration of Cl2. At least I can, if the question is to write the rate law, we can write this much. The problem is with the powers. So let the powers are x and y. Okay. Now in this case, it is said that if the concentration of both the reactant is double, then rate increases by a factor of 8. They are doubling both, and then rate of reaction changes by 8 factor. Just leave this part. Just think about those part where they are changing only one reactant. If they are changing both the reactant, we'll deal it afterward. So here it is given that if the concentration of Cl2 is double, the rate doubles. So if I'm doubling the concentration of Cl2, so let's talk about the second part first. So rate will change if I'm doubling it. So NO raised to x, and it is given that if I'm doubling the concentration of Cl2, this y, then how many times the rate of reaction changes? 2 times. And the rate of reaction changes 2 times means which number is getting out from this? The 2 is coming outside. 2 is coming outside means there is no change in number. So what will be the value of y? That means what will be the power, so that 2 will come as a 2 only. So the power is going to be 1. That means here at least I come to know that the y value is equal to 1, because the change in concentration of the reactant produces the same change in the rate of reaction. That means the number which is getting outside from the coming outside from the bracket, that number is not changing it, and it is possible only when the power is 1. Okay, now let's back to the first case. It is said that if the concentration of both is doubled, so K into NO raised to X, NO raised to X, and Cl2 is also double, raised to Y. But finally here I got the value of Y, so here I can say it is going to be 1 only. So if the power is 1, so at least I can say from here the 2 will come outside. Now the question is what number will come outside from here. And in question it is given that the rate of reaction changes by 8 times. So I have to just think which number will come outside from here, so that after the multiplication I will get 8. So simply I can say to get the 8, the 4 should come outside. And if the 4 is getting outside, 4 from the 2, so what will be the value of X, so that the 4 will come outside? So simply I will say the value of X is going to be 2. Because if it is a 2, then only 2 will get converted into 4. So finally I got a power that is a 2 and 1 simply. So this is a way how we can solve. So, and suppose if it is written, for example, that if the concentration of Cl2 is double, the rate of reaction get increases by 4 times. So if I am doubling the concentration of Cl2, rate of reaction increases by 4 times, means 2 is getting outside in the form of 4. That is the power is going to be 2. Okay. But it is not given. So this is a way how we can calculate the values of X and Y without solving anything, just by using these simple concept. Now let us see how to solve the numericals to get the answer. So solution. To get the order of a reaction, we have to determine the rate law. So we have two reactants, that is NO and Cl2. Now how to solve it, the same question systematically. So the rate law is not given, so we can assume it that let rate is equal to K into concentration of NO and Cl2. As I said, we can write at least this much. And the powers which is not known, so I can consider the power as a X and Y. So this is the rate law. Equation number 1, let us consider it. Now it is given the condition number 1, that if the concentration of NO and Cl2 is doubled. So if it is double, so new rate will be, we will get a new rate dash is equal to K into NO is double, 2 moles of NO raised to X and 2 moles of Cl2 raised to Y. So will be 2 will come from this, so 2 raised to X, from here 2 raised to Y into K into NO and then raised to X and Cl2 raised to Y. So we got a formula for the rate dash, and it is said that if the concentration of both the reactant is double, then rate of reaction is increases by a factor of 8. That is, a new rate is 8 times of original rate. This is the increased. Therefore I can say that rate dash upon rate is equal to 8. Rate dash is this upon rate. If I'm after substituting the values, something will get cancelled, like KK will get cancelled, NO will get cancelled, Cl2 will get cancelled. So what will be the left? The left quantity is only from here. From this everything is cancelled. So it will be 2 raised to X into 2 raised to Y is equal to 8. The base is same, so I can say 2 raised to X plus Y is equal to 8 can be written as 2 raised to 3. So X plus Y is equal to 3. That this is equation number 2. Okay. Now after this, we just did the first part now the second part. But when only the concentration of Cl2 is double, that is, on doubling the concentration of Cl2, the rate doubles, the rate of reaction doubles. So the new rate, if I am doubling the concentration of Cl2 now, so rate double dash is equal to, here we are doubling only the concentration of Cl2, so it is going to be K into 2 moles of, it's only NO, not it's only Cl2. We are not doubling the concentration of NO, so it will remain as only NO. So NO raised to X and Cl2, which is double now, so 2 Cl2 raised to 1. So here I can say that the 2 will come outside, it will be in the form of 2 raised to Y, and then K into NO raised to X, and then Cl2 raised to Y. Now it says that if the concentration of Cl2 is double, the rate is also double. So new rate, that is rate double dash, is equal to the twice of original rate. And this change has taken place because of the doubling of the concentration of Cl2. So I can say rate double dash upon rate is equal to 2. Now rate double dash is 2 raised to Y upon this, upon rate is this. So if I'm substituting the value, this K, NO raised to X and Cl2 raised to Y will get cancelled. So only the left amount is 2 raised to Y. So this 2 raised to Y is 2, or I can say 2 raised to 1. So here the Y value is 1. So the Y is 1. Y means the power of Cl2. So now I can say, to get the value of X, substitute this Y is equal to 1 in this equation. So substituting in equation 2. So we will get the value of X as a 2. So we get a value for X also. Now I can write rate law. So from this, from equation 1, I can say rate is equal to K into molar concentration of NO raised to X, that is 2, and Cl2 raised to 1. This is the rate law now. This is from 1 we got. And the order, the question is that what is the order of reaction? So order is going to be the sum of power, that is 2 plus 1. So the reaction is third order. Here I can say that the rate of the reaction or order of reaction with respect to NO is 2, and the order of reaction with respect to Cl2 is 1, and the overall order of reaction is 3. That is a third order reaction.